Good evening, Bearcats. This is going to be primarily 1.3, but we're going to finish our notes from 1.2, which will help you with some of the worksheet that you're going to do tomorrow in class. We're going to talk a little bit about rational expressions. If you can remember about rational expressions, they come in that form where you have like a polynomial in the numerator and a polynomial in the denominator. By nature, parent graph or base graph, they look a lot like this, many of them. But there are all sorts of, that has both a horizontal and a vertical asymptote. You can have slant asymptotes. I'm just going to give you an example where your graph would be maybe in here and in here. And they look in all sorts of forms. I'm sure that seems somewhat familiar to you from Algebra 2, but I just want to go back over the rules a little bit, how we find these things. And then we're going to work a problem together in a few minutes. Okay, so vertical asymptotes, the asymptotes that go this way. What that means is those are the things that the values that x cannot be, so the restrictions on your domain. And we've talked about that already. So in a fraction, our problem is always in the denominator of our fraction that it cannot equal 0. So our vertical asymptotes are determined by what makes the denominator, and I'm going to abbreviate 0, or what makes the bottom of your fraction 0. And those will give you your values, your restrictions, which will be your asymptotes, your vertical asymptotes. Our equations will not cross vertical asymptotes. Now, occasionally you can cross a horizontal asymptote, but they really don't cross vertical asymptotes very often. All right. Next, let's talk about horizontal asymptotes. There are horizontal asymptotes. We're comparing the degree of the numerator to the degree of the denominator. And just to refresh your memory, that the degree is the power. It's the highest power in the numerator versus the highest power in the denominator. We're going to compare those things. Remember, I'm just going to refresh your memory. We'll do this in a few minutes. But remember, now mine are kind of simple, and you may have learned it a little differently, but I think there are 3 cases. Your degree in the top could be greater, so bigger in the top. Your degree in the top could be smaller. And your degree in the top could be the same. Okay, so they could be the same as the bottom, they could be smaller at the top, they could be bigger at the top. The numerator could be bigger, degree, higher degree, or smaller degree, or the same degree as the numerator, as the denominator. So that's what I look at it. Now I think of it this way. If the top is bigger, if the degree in the top is bigger, I have none. I have no horizontal asymptotes. So if things are bigger in life, you usually don't have any problems. You have no problems is how I think of it, or none. Smaller. If it is smaller in the top, if the degree at the top is smaller than the denominator, then you're going to have y equals 0 as your horizontal asymptote. If the degree in the top and the bottom are the same, then you're going to go back to the coefficient, that number in front. And whatever that coefficient is, over the denominator coefficient, that will be your horizontal asymptote. All right, let's talk briefly about slant asymptotes. You have a slant asymptote, possibly have a slant asymptote, if you have no horizontal asymptotes. So if you have no horizontal asymptotes and the degree in the numerator is bigger by 1. So it's greater by 1 degree, then you possibly have a slant asymptote. And we will use long division, synthetic division to find that. You'll see that in an example in a few minutes. And hopefully that sort of jogs your memory. Of course, the x and y intercept's pretty self-explanatory. The x-intercept is when y is 0, and the y-intercept is when x is 0. And you can simply just substitute that in. All right, that's just a quick overview for rational expressions or rational equations. And we'll do an example in a few minutes, and then we'll go over that a little bit more as time goes by. So you may want to pause and take your notes and make the notes that are helpful to you, and then I'll be right here waiting for you, and we're going to go over symmetry. Okay, let's talk a little bit about symmetry. Now this is a new concept, algebraic symmetry, determining. Now, the fact that a graph is symmetric, that is not new to you. You are familiar with that. I'm going to go over a few examples. So if you have a quadratic, centered at the origin, the vertex is at the origin. This is symmetric. Your line of symmetry runs right down the middle of it, and it would be the same on the left and the right, and so it would be symmetric with the y-axis. with the y-axis. Conversely, if you have a conic section, this would be symmetric with the x-axis. And then one of our functions, our cube root function, oops, I didn't do a very good job of that. All right, so this would be symmetric with the origin as well. So it's supposed, you can't fold it to the left or down, but if you fold it on the y equals line, it would be symmetric there. A better example of that, I'm going to erase that. I'm not really wild about that example. Better example, let me give you an example for origin symmetry. Let's go the famous circle. Circle. Oh, hello. There we go. The famous circle centered at the origin. All right, so it would be y-axis symmetry, x-axis symmetry, and if I drew that little y equals x line in there and folded it on that line, it would also have origin symmetry. That's a really good one to look at. We'll see a few others graphically as we move along. All right, let's talk about the algebraic test. If we want to check for x-axis symmetry, we're going to replace the y with negative y, solve it or simplify it, and see if it comes back to the original equation. So let's do that in our first example. I'm going to use this example here, and we're going to replace our y value with a negative y. So we're going to have x minus, I'm going to put in parentheses, negative y squared equals 0. When I take a negative and I square it, of course it's going to become positive again, so it would just come back to its original form, x minus y squared equals 0. Okay, so it comes back to its original form. So it's not going to change anything, so you would have x-axis symmetry. Now, let's take a look at y-axis symmetry. Y-axis symmetry. Let's use the bottom one for y-axis symmetry. That's when we change the x value. So let's do that one over here. So we would have y equals 1 over, and let's make the x a negative squared plus 1. Look at it, when we square a negative, it's going to become positive, and you would end up back with 1 over x squared plus 1, which is the same as the original, and it would have y-axis symmetry. Finally, let's do the algebraic test for origin. That's where we're going to replace both x and y with a negative. And this one's a little tricky, so you have to be really careful with your math skills here. So I'm going to take the y and make it negative, and I'm going to take the x and make it negative, and let's see where we're going. All right, so I'm going to have y, so a negative y equals a negative x over a negative x squared plus 1. Okay, the first thing I do, I know that if I square something, it's going to be positive, so I have a negative y equals a negative x over x squared plus 1. This makes my fraction on the right side negative. I'm going to extract that negative out in front of my fraction. So I'm going to make this a negative y equals a negative fraction, so x over x squared plus 1. Now, if I multiply both sides by a negative 1, I would end up with y equals positive x over x squared plus 1, which brings me back to where I started. Those two would be equivalent, and so we would have origin symmetry in that case. All right, I'm going to have you pause, make sure you write your notes down and are really comfortable with this, because this will come up on a test and you're going to want to know how to find your symmetry algebraically. Okay, the next thing we're going to do is we're going to look at 2 problems from your worksheet that you'll be working on in class tomorrow. So if you have these in your notes, again, I will check them off, and you will not have to do these on the worksheet tomorrow. You'll already have them done. And this is going to review a lot of our skills. The first thing we're going to look at is an absolute value, and this happens to be in transformation form, which is really nice for us. So we're going to be able to graph this by transformation. The first thing I'm going to do is think of what my parent graph would look like. My parent graph would be simply y, or my base graph would be y equals the absolute value of x. Now, I'm a big transformation person, so I'm going to go back and put my parent graph on there. That's just simply if x is 0, y would be 0. If x is 1, y would be 1, 2, 2, 3, 3. If x were negative 1, it would be positive 1. Negative 2, y would be positive 2. Negative 3, y would be positive 3. And that's just really just a brief little picture of what my graph looks like. So one thing that should jog your memory is an absolute value graph is a V-shaped graph, a V-shaped graph. Now we're going to look at those transformations. Let's put those in another color. Let's look at those transformations. All right, first remember from last year, when we do transformations, we always do our horizontal transformations first, and then we do our vertical. So our horizontal has to do with x, so we're going to look inside at x. And I always like to say x says kind of the opposite of what you think. So when that says x plus 3, we're really going to go to the left 3. So our first transformation would be left 3. I'm going to put a little arrow to the left. It's a very big visual. Then I'm going to go back to the front of my equation. I have this negative sign. And this is everything else now will be vertical. This is a negative, which means a reflection, and because we're reflecting vertically, you'll be reflecting over the x-axis. So a reflection over x-axis. Write my notes here. This is like my roadmap. Okay, this is kind of like my directions to get somewhere, and then I'm going to follow my directions in a minute. Then I've got 1/2. 1/2 means I'm going to compress my y values by half. In other words, if the y value is 2 and I compress it by half, the y value becomes 1. So I'm going to half my y values. So compress the y values by half. All right, and then last is the -1 at the end, which simply means to shift down 1. So down 1 and put a little arrow. All right, so let's go ahead and move our graph around and take a look at it. Let's start with the vertex point. That's the easy one. We're going to go left 3, 1, 2, 3, and we're going to go, can't reflect over the x-axis if you're on the x-axis, can't compress 0, it would still be 0, but we can go down 1, and our new vertex is going to be here. I also want to think about this. This V-shaped graph is going to be reflected, so it's going to eventually be turning downward instead of upward. Make sure that happens, then catch your careless mistakes. Let's just take another point or two, and then we'll be gone. Notice there's a very big line of symmetry here, so you find part of the graph, you can easily find the other. All right, I'm going to take the point 1. I'm going to take the point 2, 2. I think I'm going to take this point right here. And I'm going to go to the left 3, so 1, 2, 3. I'm going to reflect over the x-axis, so I'm above 2. I'm going to go to down 2. I'm going to compress by half, so I'm at -2. I'm going to be at -1, and then I'm going to go down 1. That puts my point right there. I'm going to count over to my axis of symmetry, and I'm going to count the other way and put my other point. And I would keep doing that, or I would now just count out my graph. Since I'm going down 1 over 2, I'm going to go down 1 over 2. It's going to be the same, and I would end up having my absolute value graph. All right, go Bearcats. Let's go ahead and pause, and then we'll go back and work on this rational expression. Okay, let's take a look at this rational expression. It's a rational expression we talked about earlier of a polynomial at the top, a polynomial at the bottom. Notice that the degree in the top is 2 and the degree in the bottom is 1. So we're larger in the top. Greater in the top means we have no horizontal asymptote, but it means that we could have a slant asymptote. So the first thing I do is kind of analyze things, and I think, ooh, I could have a slant. All right, I could have a slant. And I'm going to go ahead and figure that out in just a minute. Before I do, I'm going to go ahead and find my vertical asymptote. The vertical asymptote, remember, are our domain restrictions. In a fraction, the only restriction we have is we cannot have a 0 in the denominator. So in this case, 2 would create a 0. So 2 is our restriction. So x cannot equal 2, which becomes our asymptote, our vertical asymptote. So we're going to count to 2, and we're going to draw in our vertical asymptote. I'm going to kind of wiggle that in green. All right, so that's our vertical asymptote. Now let's go ahead and set up our horizontal asymptote. Now we're going to go ahead and use long division, which is something you may have forgotten how to do, but it's just like old-fashioned division. So I'm going to set up x squared minus 7x plus 12, and I'm going to divide by x minus 2. And remember, we're just looking for the linear equation when we synthetically divide. So x goes into x squared x times, so x times x would give me x squared, and x times -2 is -2x. And then remember, like old-fashioned division, we're really subtracting everything, so this becomes a negative, this becomes a positive. Draw a line and add down. Those should cancel. -7, +2 becomes a -5x plus 12. And then x goes in times what gives me -5x, that would be a -5. And really we can stop there because we're just looking for this linear equation. So the linear equation is y equals x minus 5, which is your slant asymptote. So if you were to have to write that out, you would write y equals x minus 5. So we're going to go to the y-intercept of -5, 1, 2, 3, 4, 5. And our slope is 1, so it's up 1 over 1, up 1 over 1, up 1 over 1. So this is my slant asymptote. And down 1, and down 1, and down 1, and down 1, and down 1. So there's my slant asymptote. So now what we know is we're going to either have our graph in this corner and this corner, or we're going to have it over on this side and this side. We need to figure that out. I just create a t-table, x and y t-table, and I just start testing some points. Now, what may help me is to factor this out. I'm going to factor this out and make this x, and what, 3 and 4, and both are negative. Because it may make it easier when I substitute into my graph. So what I'm going to do is I'm going to test a point on the left and the right of my vertical asymptote. The left and the right of my vertical asymptote. So when I test a point on the left of my vertical asymptote, I'm going to pick an easy point. I'm going to pick 0. So if I pick 0 and I plug 0 into everything, I'm going to use this form. It'd be easy. That'd be 0. That'd be 0. That would leave me 12. That would leave me negative 2. 12 over negative 2 is negative 6. So negative 6. That's a point on this graph. So at 0, negative 6. So 1, 2, 3, 4, 5, 6. So I have a point right there. So I'm guessing I'm going to be in these 2 sections right here, most likely. Most likely. All right, let's pick a couple more points. I'll pick 1. That gets me another point on the left. If I pick 1 and I plug in, now here's where it might be easy. If I put a 1 here, I get negative 2. If I put a 1 here, I get negative 3. So negative 2 times negative 3 is a positive 6. And if I put a 1 here, I get a negative 1. Positive 6 over negative 1 will give me a negative 6. Oh, that's kind of interesting. So at 1, I'm also at negative 6. Oh, that must mean that it follows this asymptote. It goes up a little higher and comes back down to follow this asymptote. All right, there's one branch of our rational expression. So let's pick one on the right side of the graph. So since we're at 2, let's pick 3. If I plug in 3, I get a 0. So 0 on the top. Anything 0 on the top of a fraction automatically gives me 0. So I'm at 3, 0. That's a point on my graph. And for right now, that's enough. Just we're going to graph toward the asymptotes. I'm not quite sure if that goes down further and up toward this asymptote. And your graph will look something like that. Whew, that's a lot of work. Go Bearcats. All right, the last thing we're going to do is we're going to start our notes on 1.3. The first big part of this I'm going to have you do because this is really a big amount of review skills. So I'm going to go over the average rate of change. I've got the formulas here. We've already talked about that once. I've got several forms of linear equations. I've described those, and your job is to go through, write all this out in your notes in your spiral, and your job is to sketch these graphs. Sketch these graphs.